This is part 17 in a series of videos in which I'm attempting to reproduce the ADM-3A main dumb terminal PCB. In the previous videos I've got as far as being able to display text on the screen, making sure the memory refresh works, all the local board functions have been tested, and in the previous video we looked at the control commands and functions that are built into the ADM unit, and I've now finished testing those. They all work fine. I haven't been able to find any faults. I've got a font programmed into the EEPROM, that's both lowercase and uppercase characters, and I've got it configured to display both lowercase and uppercase characters. So of course the next step is to actually try and communicate with an external device. This is after all what this unit is for. So what I've got here is the unit is now off its life support. It's disconnected from the lab bench supply and it's just been fed through a single transformer. Now I did wind this transformer specifically for this unit, but you probably could find some off-the-shelf transformers to do the same job. I just wanted a single transformer and it only took a couple of hours to wind, so that was fairly straightforward. I've shown transformer winding in previous videos, so I won't show that here. But the windings were the 240 volt primary, that was 800 turns. There was then a secondary for the monitor, that's 18.5 volts, and that was 60 turns. There was a plus minus 12 volts, that's 12 volt winding, and that was 40 turns on each of those windings. And then finally there was a 9 volt winding, which is for the 5 volt rail, and that was just 30 turns. I've probably over-engineered it a little bit. I've used much thicker wire for the transformer than I really needed to, but it just means I get a much more stable result and I can use the transformer for other things if I want to. I fitted most of the other power supply components. The only power supply components I haven't fitted are the ones for the monitor, because this is not the proper monitor for this unit. It's just running from the AC monitor supply direct from the transformer. So this unit does run from AC, not DC, as the actual ADM monitor does. Other than that, it's all hooked up. I've checked the plus minus 12 volt supplies. That's what these two regulators with the Starfish heat sinks are for. That's all working fine. I have been through, I've checked to make sure that we're getting data going through to the 1488 line driver, and we already know that data, if it can come in through the 1489, will make its way through to RAM and hence onto the display. So there's only one thing left to do, and that's hook it up to a PC and see if we can actually communicate. I've already got it plugged in. I've got it connected to HyperTerminal. So I'll bring HyperTerminal up in the corner of the screen as usual. In fact, I'll bring it up in this corner. Okay, so we've got HyperTerminal showing in the corner of the screen. I haven't properly configured the ADM yet, so we might get some odd characters, but I'm just here trying to see if we can fundamentally send data between the two units. So we'll start by trying to send a character from the ADM through to HyperTerminal. So we can see the character is appearing on the screen. I have local echo turned on, of course, and we can also see that the character is successfully appearing in the HyperTerminal window. So I'll try a few other characters. And as we can see, it's working fine. We're getting the characters echoed locally to the ADM screen and also to the HyperTerminal window. So what I'll do now is try typing on the PC keyboard and see if we can get some data coming back in to the ADM through the RS232 in channel, and the data should come through the gates that we looked at in a previous video, be put into the RAM and then be displayed on the screen. And as we can see, that works fine as well. So the next thing I'll try doing is sending a file from the PC and see if the ADM is capable of streaming data at higher speed. Okay, so as we can see, the file is appearing on the screen, or at least the text from the file is appearing on the screen. The beeping is because I've got the bell sounder on, and it's set to beep as the line end approaches. It's just like a warning, as there was on the old teletypes, to let you know that you're getting towards the end of the line. And it gets irritating. This was what we were saying in previous videos about the bell defeat option is quite useful because the sounder can get annoying, but that's why it's beeping. I've left it on for now because I do want to test that, and again it's testing that the counter that detects the end of line is also working. And as you can see, the entire terminal is working, very badly distorted of course on the screen. Like I said, this is not the correct monitor for this, so it's very compressed at the bottom, but hopefully you can see that it is working the way it's intended to. It seems to be working in an identical fashion to the original board that I have here. All the functions seem to work. I haven't found any errors yet. And so what I'll do now is I'll carry on going through the serial communications. I'll try it at all different baud rates. I'll try all the various settings for stop bits and parity, this sort of thing, make sure they all work. And then the final thing to check will be the second RS-232 channel, and then finally I'll just fit the remaining components for the monitor power supply, but that's very easy. I don't think there'll be any issues with that. So we're getting very close now, and once this testing's done, a few more hours testing, and assuming I don't find any faults, then the next thing to do will be to start looking at a suitable keyboard arrangement.